Okay, it'll probably be another 5 or 10 minutes with this radio this morning. Okay, so I've soldered this back in. I've soldered this connection here. You know what, that doesn't look good. So the wire that this resistor is soldered to, I don't know if you can see this or not, is green. It's green, some kind of corrosion on it. It looks like it just won't take the solder here. Let me try a different solder. First solder I used didn't have any rosin in it. This is rosin core solder. Here, let's try this. So I'm going to plug the radio in. I'm going to plug it into a, I guess you can call it a safety system, called a dim bulb system. Involves a couple of incandescent light bulbs, and it's very simple. You're just running the power to the radio through the incandescent light bulbs. That looks good. The idea there is, first you're going to have a bit of voltage drop in the light bulbs, so you're not going to get a full 117 or whatever it is today. Be close. A little radio like this doesn't draw a lot of current. But the real thing is, if there's a short circuit, for instance, if I just attach that power cord wrong, if I did something stupid, and you know, hey, it's not beyond me to do stupid things, that's for sure. What will happen is the lights will come on very, very bright. Okay, so the dim bulbs are here. There's two of them. I have two of them, so I can decide if I want both in or just one in. Power runs through these bulbs if I throw these switches here. If I throw this switch downward, power runs through the bulbs and arrives here. And just so you know, this is not plugged straight into the wall or anything like that. This is going into a transformer which provides isolation from the power system. It can still produce a lot of power, it's a big transformer, but there's no ground coming through. Even though this thing I have plugged into this extension cord is a 3-pronger, the third prong is just hanging in the air here. It's not doing anything. This is a handy little device. It will tell you the amount of power you're drawing, the voltage at the outlet, and other things like that. It's great. It's handy. So, are we ready? So first of all, make sure I know which is the volume. Of course, this is pretty easy. This is obviously, excuse me. Hey, what happened? What's happening here? How come it's... Uh-oh. So I've had this riding right on the bench here. We can't have that. So we're gonna elevate the front here a little bit. Yeah, this is very tight. This is too tight. This is way too tight. Let's figure that out. The tightness can easily be right in here. Very often that's where it is. Oops. No, down here. Right in here. So we're going to hit that. Just a dab WD-40, but we're going to do it from in behind here because we don't want to get it on the string. So see, it's a pretty long deal. That's to make sure the knob doesn't wiggle up and down. So they make a pretty long fitting here. And you know, loosen it right up. There we go. So that was part of the tightness. There might be a little bit up in here too. We'll get to that. But this is much better just like that. Get it back on the plates. Power's off. So first we want to know the on-off switch works. So I have it switched off. We're going to plug it in. This polarized plug thing means nothing in my shop when I plug in here. It doesn't mean a thing. What's going to mean something are these lights. Okay, so I'm going to throw one switch here. This is to arm my system. It's armed. And you've also probably noticed this guy This guy here, he's just set to 117. I often don't use this. This is actually another very good way to control the voltage. You can turn this dial and then feed this thing with 30 volts, 40 volts, all the way up to 160 or something like that. But I like the lights, because the lights are in your face. You can't miss the lights. I like the lights. Okay, we're going to hit the power. Nothing should happen. Nothing has happened. So you can see this guy's come on. He's reporting 118 volts. That's pretty much exactly what this pointer is saying. Now I could turn the switch, but I'd rather just turn off the power. Turn the switch. Volume is low. In a beat up radio, what you would expect is turn on the power and come out of the speaker pretty quick. And that would be all you need on a beat up old radio that hasn't been worked on. But this guy's been worked on. So chances are it's a thumbs up situation. If I keep the volume low, here we go. This is it. Watch those lights. So I saw I saw this light come on. I saw the tube here burst into a beautiful glow. And these guys came on and they just went down. We have 113 volts, which is more than sufficient to operate the radio. You see this light is getting brighter now as the tubes are beginning to conduct. You can actually leave these lights in the circuit in case something happens. Now what do you hear? I hear a little bit. Let's turn it up. Well, that's not very normal. That's... By the way, in looking at the speaker, which I didn't look at earlier, there's a nick there, but there's these cracks here and here, which is indication that this is beginning to break down. Now it's probably got another 100 years left in it, but in some speakers these cracks are endemic all the way around and you have to patch them up. This is a fair size speaker for a little radio too. Let's turn it back up. Can we get anything? Sure. So clearly the radio's working. Okay, so these are typical sounds in my shop. This sound. What it's from, I don't know. We should get a station around here. Yep. Happens to be lining up with that dot. That's the third dot in. It's supposed to be 600. So the radio is supposed to be picking up 600 here. I'm guessing this is 6... I don't know. Let's wait. I'm gonna wait. Let's go find another station. Oh, so that must be the shutoff it was talking about. Tune it all the way to one side, and the radio goes silent. Can we see the plate that he bent? It's one of the plates. Wow, it's very subtle. If I was expecting to see a real sharp bend. The problem with this, first of all, you can't use the phono anymore, so you don't need the shutoff thing. And secondly, there's some stations down here. This thing is shutting off too early. You can see there's still quite a bit of capacitor to go here. Shuts off there. You still got all that. Oh, kind of a come and go deal. Clearly that's not the best way to do things. That's a cheap, easy way out. You could kind of see the salespeople having a meeting with the engineering department, and the salespeople say, "Look, we've sold 50 of these radios," and people are calling back, "No, I can't play records because I keep hearing the radio." And then some engineer said, "Oh, I know what we can do. We'll just bend the plate. We'll just bend the plate. Don't redesign the radio. Bend the plate." That would be some old guy in the back of the room. "Hey, just bend the plate." Well, I'm going to unbend that plate, I'm pretty sure. Let's go back and get the station.
Well, I mean, we definitely didn't start off the way we wanted to this year. But it was kind of expected, you know, we were in ball club.
30 volume control.
You know, weather playing in Buffalo when we got here.
Okay, so he's talking about sports. So that is 590. 590 gain, where the dot is supposed to be 600. So, you know, that's really good. That's really close. So that tells me the last guy probably did a proper alignment on this radio. That also tells me there's probably not much more to get out of it than what it can do right now. Let's go find a station up around here. Antenna, I got to get the antenna set here. The thing about these radios is if you have them positioned just wrong, the station you're after you will not get, because these antennas have a deep null. And if it just so happens you set it on your counter where you want to have it, it could be the antenna is aimed inappropriately. See what I mean? Nothing. Oh, this radio doesn't work. Sure it does. So we can tell from this, this is the way to Toronto. So another Toronto station should be right around here. Just I'm trying to get 680. Another station I can get here up in this area. The radio's getting quieter as we go. Not much, a little bit. Nothing. So, if this fellow who did the work on the radio did not have a bench full of crazy equipment like what I've got here, he may have done the alignment just by tuning in a popular radio station and using that and just aligning everything against a radio station. It's not the worst thing to do. For sure, that station is going to come out great, but you may accidentally kind of wreck the rest of the band, if you like. Now, in the area I live in, all the stations of interest, 2 or 3 of them are down here. So it's really quite an attraction to just align the radio to work really well down here and don't worry too much about up at the other end. And who's listening to AM radio very much anyway? And probably what do you listen to? You probably listen to sports talk, 590. So we don't know what he did. We don't know. So generally speaking, at this point I've finished the radio. The radio's fixed, working. Could put that capacitor in. It's not affecting the operation of the radio. The problem with the capacitor that's cut and not connected, if it's doing what I think it's supposed to do, which is just get rid of a little bit of RF that may have made it all the way there, the problem is you've let the RF get into the speaker output transformer here, and that's probably not the best thing. I think it's probably a minor issue. It's probably worth a little capacitor to fix it. But if you don't have it, it probably remains a minor issue. Unless you plan to fill a gymnasium and want to turn this thing right up, maybe it means nothing. So dirt on the volume control. Okay, let's check the switch. Very good. Dirt on the volume control. So we will get rid of that. Now this is plugged in, the power is on. Don't stick your fingers under there, Jim. Turn the power off. Turn the power off. In fact, my practice in my shop is to pull the plug out and see the physical isolation. The volume control. Now the way it's installed is perfect. I want to throw a little bit of cleaner in there. And lo and behold, after doing this for 10 years, I finally bought this stuff. Personally, I'm not enamored to this. This is really expensive stuff. I've always used WD-40. People lose their mind over WD-40. What do you think the difference is between these things anyway? We can't know for sure. They're both secret formulas. My guess is there isn't much difference at all. I've never fired this one. This is the first shot with it. Flushing action. So yeah, to a large degree when you're using these things, you're spraying them in on something, you're spraying enough stuff to wash stuff away, to wash it away. That's not what I'm doing here. I'm going to put a little in, work the control, plugs out. Let's turn it on here. You know, I like to do this with the radio operating actually, because it's exciting. Let's do it with the radio operating. Power on. Power on. Small risk of setting a fire. Very small risk. So. Okay, right in here. There's air. That's it. Okay, don't need to turn it all the way up with the power on, but you do want to turn it all the way to its limits. You're basically clearing the runway. You're skidding the plane down the runway, up and down the runway, and cleaning off the runway. Lovely. Turn it off. Because I really should put this proper capacitor in. And then it's all about alignment, which I'm going to guess is going to be okay. So wow, okay, so I've done a long video here. I may split this in two videos. But, okay, and we need to do something about this cord to make it more secure than it is. I'll think a little bit about that. Great. Okay, why not? You know, this is going to be a one long video, start to finish. That's what's happening here. So I'm going to cut this capacitor out. I see this capacitor sitting right here. There may be charge in here. There'd be almost certainly charge left in these. Not necessarily, but almost certainly. So it could be a little bit of a bang or a pop. You got to be kind of ready. You see, if there's a big pop, I'm going to go like this and smash my camera. I don't think there's going to be a pop though. I'm going to cut this guy out of here. This is the moment where you accidentally grab two wires. You cut the one you want and the one you don't want, but you don't know you cut the one you didn't want to cut. And this is supposed to be a what? 0.022. That's the same as a 0.02. So I'm going to put a 0.02 tubular capacitor in there. Okay, so I have the new capacitor in here. Soldered up. Left a lead wire hanging out. Old lead wire. And this is where you cut the wrong wire. Cut two wires, thinking you're cutting one. The leftover bit of wire there is just ready to make a short. I'm just going to bend it. There we go. Good show. Now the easiest and I think best thing to do about this power cord is simply put another one of these on the other side to keep it from doing this, coming in. So I'm just going to use this. That's rather than go through all the trouble of trying to install a grommet here and then in the end not getting it installed. Now the way you tighten these guys up, grab them here and twist. Twist, baby. Come on. Click. That is tight. It's a little ugly, but not terribly ugly. Not like a grommet is a thing of beauty. There we go. Okay, capacitor done, connection soldered, power cord stabilized, more or less. Let's just see if it doesn't. Yeah, it's not going to come off this terminal. I've got it soldered on there quite nicely. This should kind of tuck in a little bit, but it doesn't really matter. That's it for the radio. So, like I say, I can't decide what to do. There should be one really long video, or I'm going to make this into two. I'm going to make it into two videos. So I don't know where I've split it. I have split it somewhere though, and you are now watching the second half. And it's all about alignment now. And that is coming next. Fantastic. Okay, so what I've done is I've set up a sweep generator here, and I've got it sweeping through the IF frequency. It must be 455. Yes, 455. Written on the sheet here. You can see on the scope the kind of shape I'm getting. Here's just a wee bit better view of it. Not bad. Now, we gotta really wonder, so what frequency is that? That should be 455 right there. You can see I have my alignment tool in my hand. See the number up there? 427. Okay, so what I'm going to do is I'm going to give you the close-up of the camera. I'm going to tell you what frequency I'm dialing up. This will be the marker frequency, and you'll see an effect on here. It should tell us what frequency it's at. In fact, the effect is there right now. So there's something going on right here. Let me just back this off. Okay. So now the marker frequency is set to 416 kilohertz. I'm going to advance it until we see it come in and show up right on this point here. So I'm looking at the scope just like you. Okay, now it's tricky. It's not really a point. I'd say that right there. Now the radio is still receiving stuff. Let me flip back. Voila, 427. The way I've got the sweep and the marker generator connected is just using this coil, just hanging here. It's just a long clip lead. And I've got the two signal generators feeding their signals into this coil. That's getting into the radio either from the antenna or perhaps even through this coil here. Probably the antenna is doing it. So what's this telling me? So, okay, so this is telling me that probably the fellow who did this work did not have the equipment I have, a sweep generator in particular, although he could do this with just a single frequency generator. He may not have had the equipment necessary to do the alignment, and he's done it by ear, and he's done it around one key station, which is probably 590, the one that we picked up, which is an important station to pick up with AM radio around here. And he's got the radio working really good there. It's not working good anywhere else. With the IF off, the radio will be shifted. He will have compensated by fooling around with the oscillator to get the oscillator setting to get the radio to receive 590 F590 on the dial. Beyond that, it's kind of a could be a wash, in fact, especially in the higher end of the band. Okay, so the first order of business, and just another assumption on my part, the fellow who did this knew what he was doing. He's well known. So is there a chance this is what had to be done to this radio to get it to work as well as it does? And so because there are ways to compensate for dial accuracy problems, and by shifting the IF frequency to something else. My only option here, I mean, I know he's got it at 427, 428, so I can always return it to there, but I think I really should move it up to 455. Now let's just be sure. I'll dial in 455, and you watch what happens on the scope, and maybe I can make this just a little more apparent here. Yeah, that really makes it apparent. I can move up towards. So what happened there was I changed the relative strength of the sweep signal and the marker signal in favor of the marker signal. So I'm up to 455 and it's appearing nowhere in here. I go back down. Swoosh. So the swoosh is very, very convincing that this radio's misaligned. Okay, so we want to get it to where we want it to go. That's a long ways off. I think I would be better off to kind of ignore the sweep. Pay attention to what's going on with this guy. So I'm going to stop the sweep. In fact, I'm going to kill it right off. Kill it, no, kill it. Gone. Okay, I want my scope sitting still. Now it's a question of listening. This is not modulated. Now it is. Okay, 30%. So if I put this all the way up to 455 and then go hunting, I've got 4 slugs I got to get there. I'm probably not going to get there. By the time I get somewhere around 455, they're all going to be like this, something like that. I may not even hear it. So I'm going to inch my way up there. So I'm going to move this in the direction I want to go until I can still hear it. It's barely there. Now I'm going to try to pick it up by doing the alignment operation here. Okay, should really start, well, it doesn't really matter in this case, but you would normally start with the second IF. Okay, what's going on? Uh-oh, what's happening there? How come that didn't go in? That's kind of weird. Hey, this has got a big hole. This has got a small hole. A big hole, big slug, big tool. What's going on inside there? Is that a capacitor right up in there? How am I going to get a look in there? Okay, I'm going to take off my scope here very carefully. By the way, my scope was not grounded to the chassis, not in this radio. It was grounded to the B-, and the reason I can do that and not panic about anything is because, again, this is plugged into an isolation transformer. If it wasn't, I would be much more cautious about doing any of this stuff. Much more cautious on these 5-tube, okay, 6-tube radios. Well, maybe I can look up from underneath here and see something. Let me get my blaster light out. And the answer is no, it's blocked from view. Okay, so we're going to come around this way. I'm going to try to look in there. What do I see? Screw. So we got, that's interesting. We got a slug in one and a screw in the other. Does that show up on the schematic here? Did they indicate it somehow? No, it doesn't show up. So I would think they put a variable indicator on these, or on one of these anyway. No, this shows the slug moving. What's happening? Okay, so I got a screwdriver end here. Yeah, that's not going to work well. So I'm going to try what a lot of people would say, no, you can't do that. I'm going to use a little metal screwdriver. Okay, it's just going to turn it up a little bit. Check to see if this does any funny stuff. No. You know, there's a little bit of cardboard insulation right here to keep my tool from touching the can. Pretty sure that's what that's there for. Same thing up here. Although it's shrunk back a bit. Okay, so going in, not affecting the radio. Not going in. Did I really see it? There, it is in. Okay, objective, make it louder. So what's happened is the noise is disappearing, but it's not getting any louder. That's the automatic volume control. And probably because I have way too much signal coming into this guy. That's okay though. Well, is it? No, not really. I gotta knock it back. Okay, barely hear it now. Okay. Now I've got to come in from underneath with this. Yay. Oh no, I'm not going to do that. Okay, let me get a. I got to get a plastic tool or something safer to use here. Okay, this might be safer. Oh, this is going to be too big to go in. Ooey. Let me try this. If the screw is easy to turn, then the twistability of this plastic won't matter, but the screw is tough. Okay. Fishing my way in there. Oh, it's totally blocked. So wait a minute. This isn't working out well. So we've got the two capacitors here. They appear to be glued together. I gotta get past them to get into the get in there. Oh boy. I was halfway out of the room here. That was exciting. Yeah. It's making a run for it. Well, these are in really rigid. Well, what did he do? Did he put glue between them? They look glued. No, really? Come on. Come on, John. No, they're not glued. They're not glued. Okay, spread them apart. Down we go. Okay, I won't jump this time if the lead pops off. Come on, get in there. You know what? I can try this on the top to make sure it works on the top before I... Yeah, it goes in. The screw's not easy to turn. It doesn't feel like a screw. It's making sounds like it's a slug. Maybe it's a metal slug. Some radios have metal slugs in them. Okay, it would be tempting to hold my finger on this. No, that's not the best idea. What the heck was that? Is that something in my house turning on? Success, no. See, I didn't jump that time. I jumped a small amount. Of course, only one signal generator is running now. Okay, I need a long, slender screwdriver. A narrow, stiff, long, slender screwdriver. Yes. Yeah, it's got a nice big handle on it. Yeah, don't touch it. I'm gonna have to touch it. Okay, let me get my safety material here. I'm gonna go in. Maybe the capacitors are just making the tool slightly out of alignment here. Yeah, that's the alignment. Oh, son of a gun. That was scary. Wow. Okay, nothing bad happened. Woo! That was scary. This thing just decided to go places. Right in, right in, right in. Okay, trying to make it louder. Very good. Okay, now we got to do the other one with the white tool. What did I do with the white tool? Hey, come on. There it is right there. White tool on a white thing. Okay, working from below here. Why not? Louder. And top. A little louder. Okay, now we're going to advance this. Tune the radio to get it away from something. What if I tune it to the turn off? Yeah, that's the idea. Tune it to the turn off. Now see, every time I grab this knob, I'm grabbing the chassis. Oh, that's good. No, it isn't. That is. Okay. Tone, please. I can't get the tone past that. Because of the way I'm injecting it, I guess it's coming through the antenna, and now I've knocked the antenna out of the picture. Okay, bad idea. Back we go. Just find a quiet spot. What about a half shorted? What about that? Uh-oh, 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 we don't want to lose it. So one of the problems with finding a quiet spot on a radio like this, in this kind of environment, the modern environment, is you find a quiet spot. The reason it's quiet there is because it's actually receiving a strong, unmodulated noise signal from your house, from your computer, from who knows, from your watch, who knows where it's coming from. So you get fooled really easily. At least I do. Also, usually there's instructions to do this with the capacitor wide open or wide closed. Okay, so I'm going to call that a quiet spot right there. Okay, come on, where are you? Yep, more juice. It's gone totally away. Oh my gosh, look at that. We're almost at 455 already. How did that happen? How did that happen? That's good. Okay, back to... Okay, let's zoom in on it. I don't know how that happened, but it did. Guess maybe I'm just better at this than I realized. Okay. Just ear tuning. Okay, now the other one. To really refine this, we need to do something else. Am I just trying to get it close first time through? Actually, the first time you do an alignment on a radio is kind of like you just accept it's going to be a write-off, and it's about learning. Now, in this case again, I'm listening to the noise go down, not the signal go up. It's tricky. Tricky. What happened there? At the last minute, it's a noise thing. Okay, how good did we do here? Okay, let's go for a little trip. Very good. I'm going to close my eyes. I'm going to tune it to this where I think it is. Well, I'd say it's there. Good. My counter is a number or two low at this frequency, so that's actually 454, 455. That's good enough for now. I wonder what difference that made in the radio. We can find out easy enough. I just pull this away. Turn this down. let's I'm going to put the radio into its proper position here. Okay, I don't like moving things that are working because if I make a run for the door, it means I'm dropping it. I'm moving the power stuff around a little bit there. Okay. Okay, Mr. Radio, what can you hear now? So now we're picking up the station I made a shot at earlier. It's here. You'll have to trust me, I heard it. There it is. Or am I just hearing rumbling? Better. And we'll go down and we'll find out what happened to 590 and that stuff. Oh, I know what's wrong. I forgot. Yeah, it'd be safer if I put the knobs back on. It'd be smarter. Okay, having said that, I have to do it. Put the knobs back on. Again, this is in a isolation transformer, but as soon as a connection is made with any of my test equipment, the ground, then the isolation thing is, well, it's not what it was. So, here we are. Hit the dead spot. Antenna. So there's something there. It's not necessarily 590. Now the next two things are. So again, this is just the first time through, roughing it out here. Oh boy, this is actually, I actually want you to pump 1460 into it, right into one of the tube pins, so I'm not ready to do that quite yet. Oscillator and interstage trimmer. It's got to be oscillator and interstage trimmer. So oscillator. So we don't want to fool with the oscillator. I don't know about the frequency just yet. Let's fool with the antenna trimmer and the intermediate trimmer. So we're doing these at 1460, other end of the band. And yeah, this is just a ruffian alignment here. Take this up. 1460 must be where this dot is. So I'm going to put it there. Oh, we will find out. Bring back this thing here. Turn my signal generator into a little radio station. I'm going to put my transmitting antenna right there. 1460 it said. I didn't hear anything. Give it more juice. Hello, calling. Oh, nowhere near 1460. That was the problem. So there's 1460. Pretty close. Turn it down. Put this right on 1460. Oscillator. I'm going to use a steel screwdriver on that. check first. Didn't seem to do anything. Okay, happy there. We'll also do antenna one. Ooh, I touched something there. That sounds about the most to me. Then we go down to 600. Do the antenna. What are we doing on the antenna at 600? Check only. Check. We're doing a check only. Okay. 600. 600 must be one of those dots. 600 is third dot in. That's where we've been doing. Where we've been picking up the other station. So we really just have to see if it'll pick up that station. How about the one in here? No. It's a little off. 590 picked up at 600, so we'll call that 590 there, and we'll push the oscillator. We'll change the oscillator.
I do think that, like, the bottom line is this is
Open the oscillator all the way. That's a sign of something.
And he's a #1 center. Now,
Close it
do we
back.
have to sort all this medical stuff out? Yes, absolutely we do. But I think there's a market for that. And look,
Okay.
you know, you,
Can we get anything
every
else?
new treatment
590. Okay, 680. Right in here. Looks like a no on 680. 680 is a weaker station. 640 is in here also. Good radio would get 820, 840, I think. So that's the French station. That's not bad. That's a good indication. Okay, that's not bad for roughing it in. This center dot is 950, and I think I don't know the frequency of the French station here offhand. Not bad. Now we have to do the whole thing again, only this time use more equipment and more precision to get it just right. That's great. Okay, I have the sweep generator going again. We can turn this down. It's sweeping through the IF frequencies, causing that. Let's take a closer look at that. Now I'm going to change the frequency of my quote marker generator. See where we actually are. Okay, not there. It's here. Somewhat clumsy way of doing this. I'd say it's right there. And what does that amount to? 451. Okay, a little off. 455 is where we really want to be. Trying to decide whether I should do this looking at the scope or put a meter on here. What do they say? Now they have a much more complicated process here, but the idea for them is the radio is ridiculously out of alignment. You have to get it back in, and so you really need to follow this kind of procedure where you're feeding the signal into each stage. because they're so far out of whack. But that's not the case with a radio like this. I didn't change the IF transformers or anything like that, so it's going to be close to begin with. It's giving a sensitivity, nominal sensitivity for 50 milliwatt output. It's giving a 2000, which is probably the amount of voltage, probably microvolts, you're feeding into the pin of a tube. I'm going to not do all that, because I'm sure I can get there this way anyway. Okay, we're going to rely on the wiggly display here. Let me turn this down a little bit. Get a bigger wiggle happening. I'm going to set this up to, you know what, I should do this with an indicating meter, I think. Yeah. I was just testing myself there to see how precise I can set it. Not terribly precise. Okay, it's past lunchtime here. So we could listen to the tone coming out of the speaker and measure the voltage level there. How's the speaker done? Is the speaker isolated? So the speaker's not fully isolated. There's a connection straight to the chassis here. I didn't notice that one. So there's one there, there's one here, and there's one here. Straight to the chassis. And then there's this filter connection. I don't quite understand why it's done like that, but it is done like that. I mean, it's hooking up my test, but this whole thing, I was going to say it's isolated. No, it's not. It's got the ground there. So that's a little bit of a concern for me. I have to hook up. Well, do I? Yeah, I have the scope ground on the B minus. So if I come along and put a ground here with my other piece of equipment, I will be applying a ground through here, and through here. I don't like that idea. So I could use a digital voltmeter, but I hate doing this with digital voltmeters. I really want an indicating meter doing this kind of thing. So where else could I do this? I could pick it up off the volume control. Why not do it there? So I could take the output of the volume control and pick it up there. That would be on the grid of the 12AT6. That might mess up the rest of the radio, but it doesn't really matter. I don't think it can mess things up back this way. After all, it's a high impedance meter too. But it was pretty certain to measure to affect the sound coming out of the radio. But that won't really matter. So I go on the slider of the volume control and ground to B minus on a voltmeter. Okay, so we will use, I'm going to try doing it with this voltmeter over here. So I'm going to make sure the ground is the same place as the other ground. Big honking clip lead too, so we're going to go right in on here. Certainly is affecting the radio. Yeah, scope is on the input to the volume control. And what am I doing here? I'm about to put a voltmeter. Yeah, I'm putting the voltmeter where the scope is. Isn't that basically what I'm up to? Not quite. I'll put it on the think man, what are you doing here? Maybe it's really the AVC voltage we really want to watch. I think it might be a better idea. So I would put it right where the scope is now. Okay, I've got to fish a clip lead in there. Shut the set off and take the scope out. Yeah, I could use the scope as a voltmeter, but I really like the pointers. Okay, so we're going to go on the what is being fed to the top of the volume control. Just I got to check one more thing. So capacitor in the way there. So we're coming out of the detector, coming down, DC, DC all the way. So they're allowing DC to flow through the volume control. Right? I think that's right. I think I got it right. Voltmeter to the top of the volume control. Okay, voltmeter set on DC. Okay, set on. Watch this meter. It's on 50 volts. I don't think there's going to be 50 volts there. It's on minus. Let's see what happens. Oh, someone at my door. Okay, so if you hear a little bit of sound in the background, industrial kind of sound, that's just a dryer, clothes dryer running in the next room. So what I've done is I have decided to feed the test signal right into the grid of the 12BE6 here, as instructed here. It's going to go through both IFs, and we've got the, is that on camera there? We've got the meter here, indicating the AVC voltage that's developed by the detector. And right now, just a little hard to get both things in view. 453. So that just happens to be there. Let me move the camera way over here. Okay. A little crowded in here. So I'm going to vary the frequency I'm sending through the radio. Okay, we're going to set it to peak. Let me turn the volume up a little bit. That's the peak. Yeah, I really like indicating meters for this. And what is the frequency? 455. It's on the money. It is on the money. Is it possible for me to tune it higher? I kind of doubt it, but I do have a tool in my hand, so let me just give it a go here. We'll try one can, but I think it should be okay. Okay, here we go. A little wee bit there. Okay, a little wee bit. I'll take it. Now we're going to do the other slug. This is a little scary. Trying to get in from the bottom. Doesn't want to go. It's way up there. Can't get it in. Okay, so we're going to try from the top and push through. Didn't reach it. Can't reach it. How did I do it before? I think I put my hand on the top of the radio here. There, I'm in. Okay. Okay, back to watching the meter. And adjusting. It's pretty good. Okay, might as well do that. The other one now, the other transformer. Oh, I got so much stuff in the way here. Okay, I'm trying to get the screw on the bottom. There we are. Okay. Now we'll go the screw on the top. Okay, we're in. And these are all pretty good. Okay. Great. IF is definitely set to, yeah, that's 455, even though it says 3. And what's a couple kilohertz? Now, from here, so I'm injecting the signal here. When I have a stop, I start injecting the signal into the antenna as per the instructions, which is fashion a loop consisting of several turns of wire and radiate the signal from the generator to the loop of the receiver. Adjust trimmers for maximum output. Okay, so I'm going to turn it off here because I just got to stick my fingers too far in. Ooh, that was barely in there. We want to switch this to a loop. Could use a fancier loop. Let's use a fancy loop. Fancy dancy loop. Look at that. Oh, that's fancy. I get the impression I'm rushing. I am, because lunch has gone by. I'm missing my lunch. Okay, we'll put it about like that, so it doesn't so it's very, so there's no close coupling happening at all. It won't affect the impedance of that antenna at all. Up. What's the first frequency? What's the frequency, Kenneth? 1460. Oh, they're still saying put it on one of these. No, let's go right in from the antenna. Let's try that. 1460 oscillator and interstage trimmers. Why does it say trimmers? Interstage trimmers. Interstage coil. I don't see any thing there. That's the trimmer there. They wrote the word trim on it even. Just for me, trim. Very nice schematic. All hand done. Beautiful. Okay, okay, we'll do 1460. Oscillator and interstage trimmer. Okay, so, and we're supposed to tune the radio. It should say somewhere, doesn't it? Apply signal through dummy, set gang at 1460. Okay, so using the, gotta turn the set on again. Using the dot, that's 1460. To wait a bit. Would appear to be quite a ways off. 1515. How come? Must have missed it by a long shot last time. 1560. Okay, again, we're going to, I've got to hopscotch my way up there because I'm pretty sure I'm never going to hear it up here. Jack it up, turn it up. Barely hear it, I'll go find it. Okay, go past. Oh, 1460, I'm going the wrong way. Going the wrong way. That sounds much better. Okay, a little past. Right on 1460 now. Okay, now it's time to watch the Avc meter. You see it's pretty high. I'm going to cut back the input level. That's a little too much. Cut it back this way. Okay. And adjusting. Trying anyway. Okay, here we go. Oops. I'm using too small of a screwdriver. I need a bigger one. There we go. Uh-oh, noise right there. Okay, so what we're going to do, I'm going to tune the radio slightly off. Oh, this is problematic. Just right at 1460, there's noise. I'm going to go just below it. I'm going to pretend that's 1450. Okay, set my signal generator 1450. Tune her up. That be the spot. That be the spot. Next thing is 1460 in the antenna. So 1450, we're doing the antenna and trimmers. Interstage. Keep an eye on the meter. Let's knock this back a little more. Still a lot of noise here. And the antenna trimmer. Whoops. Okay, so it's kind of peaked up at the wrong end of the band though, but this is the instructions. Around 600, check only, and they give you a voltage, but I'm not attempting that. That's, I almost need a factory setup to do that kind of thing. So we're going to want to disconnect the voltmeter so I can lay it down and disconnect the this guy too. Okay, voltmeter off, ground off. It's all by its lonesome now. I'm going to tip this down. Every time I tip down an operating radio, I say to myself, no matter what, I can't let go of it unless I'm getting electrocuted. I would let go then. Okay. This is unnecessary. This is the sweep generator, which I should not have even had running at all. Show my scope too. Okay, it's time to test this guy. And the deal is, if it works really well, I get lunch. Signal generator off. Kill everything. Kill it all. I thought I heard a voice there, but I think there is something there. If you do this kind of work and you listen to radio noise, you start hearing voices in the noise. I do. French station. That's a pretty weak station, so getting it down here in my shop, that's pretty good. One more here. Hey, what happened? Everything went really cool. Oh, I bumped the volume. Radio loves 590. Okay, now.
Doesn't mind sharing what players are talking about. Like, man, you think for any second that Robin Leonard is the only person
Touch up on a station.
concerning himself with the situation with Jack Neighbors, or everyone in the NHL thinking, A, it's a situation that merits my attention because that might be me one day. And I don't want the same thing to happen to me.
Right on.
Robin Leonard's a very thoughtful guy as well. That's the other thing that, you know, we know about Robin Leonard. And I think other guys are absolutely worried about what's going on here because there's...
It's fine.
This is a part of a larger conversation. Some of them may just be afraid to say anything. Robin Leonard is basically...
That's the shutter down spot. That's the last thing to do. Is where is that shutter down spot? Plastic tool. So I'm looking at all these plates. Which one did they bend? Probably none of these. Oh, that looks bent. That little bit there, that looks bent. It doesn't seem to be making contact. Oh. It's bent in this shape. Like a backwards question mark. No, that's the correct question mark. It's actually contact. Let's check it. Maybe not. You're wrong. Now, a lot of these radios, these plates are bent, usually on the other end, and they're bent on purpose. And it's a factory alignment procedure to really make the dial accurate. I don't think it's here. They're killing the antenna. Let's see. Wow, it's very, very subtle. Something a little stiffer than this. Ooh. This plate looks bent. It's the only one that looks bent. What did they say about that? Exactly. In order to prevent reception when the set is used as an amplifier with a record player, the tip of one of the antenna section gang plates has been bent. So this plate shorts out when the gang is turned to its maximum capacity position. Do not remove this short. Much of a short, but it's just coming and going so easily. So, I mean, if I was going to bend a plate, well, I wouldn't bend the one that's bent. Oh, wait a minute, maybe I would. This one here. Gone away. Yeah, fix it. Not quite sure what I did there, but I did something. I notice the radio is much quieter down at this end here. Maybe not. That's it. She's golden. So in order to improve the signal here in my shop, I have this connected to a outdoor antenna by a long lead, and then it's connected to a tuned antenna system here, which I tuned. It's not connected to the radio, it's just close, just very close.
L'ouverture de la cérémonie, pour la cérémonie d'ouverture, pardonnez-moi, de l'exposition universelle.
Sunshine Band, the other get down tonight. That's the way I like it. Shake your booty. I'm the boogie man, of course, and keeping Kevin Love. Will J start at the top and Love Train. Nice to have you here. I'm Norm Edwards. It is an hour of number one hits as always with Neil Diamond in a moment. And Paul Anka, who topped the charts in 1959 with Lonely Boy, he said back then it was difficult for a Canadian.
It's picking up lots of stuff. Noise.
Obvious to everyone that, you know, O'Reilly and Shan are both 30 years old. When they're no longer a significant factor with the Blues, there's two players ready to jump into those.
Nothing down here anyway, but good. That's very convincing proof for me in my shop. That's very good reception. This radio is one step up from a 5-tube because it has an intermediate tuned circuit, which should make it work better. If I took this outside, it would be wonderful. I'm pretty sure of that. Okay, so thank you very much for watching that, and next is something quite different. The next thing that's going to be in here. So we'll see ya.
It's my understanding now, Justin, that a lot of these now, I don't believe for... 30-year-old ribbons.
The directional antenna that are in these radios, they're not so much good for aiming at the station you want. What you can do is aim at the thing you don't want. So watch this again. Now it's not that I've aimed this at the station. I'm aiming it kind of like away from the noise, so to speak. It's a very, very directional antenna when it comes to the null. So it'd be easy to tune and go right by the station. So there's nothing there. Noise is terrible. I can't stand it. Don't know what it is. We're not likely to pick anything up here. Not at this time of day. Well, there we are. I think in the evenings this would be a lot of fun to use, especially you see how I've got it on this turntable. I actually use a turntable if I'm listening to AM radio, which I do occasionally. I like to listen to faraway stuff, and I get a little transistor radio, one that's a good receiver, and I position it on top of here. Oh, I have a different table, a smaller table. And I put headphones on, so as I swing the radio around, it really doesn't matter. It's not coming out of the speaker, because that makes it sound different, you know. So by wearing headphones, you get rid of that. And away you go, trying to use the null to beat out interfering stations or other I shouldn't say beat out, just to get rid of interfering stations. Anyway, let's have a look at this radio in the complete darkness here. Okay, that was a big thrill. Okay, well, thanks for watching, and I'm going to be doing something quite different next after this. Hopefully be another quick job too. Thanks. See ya.